Am I audible? Am I audible?
Yes, sir.
Okay. Okay. Very good morning to one and all. As it is the last topic of the unit number 5, high voltage testing of electrical apparatus, and last apparatus that we are going to understand today. So that is again, it is about the uh, testing of surge diverters and what are the radio interference measurements. That point today we are going to cover. Okay, so first of all, you all should know what does it mean by surge diverters or surge. It sometimes it may be known as a surge arresters, or sometimes it may be known as a lightning arresters. Okay, so in today's life, that lightning arresters or the surge arrestor, that are the most important apparatus. Why? Because it is required to provide the protection for the our power system whenever there is a transient voltages which are occurring due to the lightning as well as switching surges, right? So this is very important, and as per me it is very important point of discussion, and we should study for the whatever the surge diverter or a lightning arrestor is there. So of important factor about that, you should just keep in mind that this power or surge diverter that is mostly used for the protection of power system whenever there is a transient voltages occurring due to the lightning surges or the switching surges. So at that time there is a excessive voltage. So that excessive voltage, with the help of these whatever surge diverters are there, that may take it to the grounds. Okay, so whenever there is a distribution voltages like 400 volt, as we know that 440 volt three phase supply that is coming up to our farming stations or at our homes. Okay, so this kind of surge diverters can be used from the range of 400 volt of the voltages to the highest transmission voltage level, and that should be around 765 kilovolt. So you can understand that here, from 400 volt to the 765 kilovolt. So that is the operating range of the surge diverters, and sometimes we can say that is again above the 765. So in such conditions, we need to operate, or we need to take testings of such surge diverters in the laboratories, and there also there are some standard test procedures, right? So due to the testings which we are conducting into our standard laboratories, that are important in our modern power system, because these surge diverters which are playing very important role in a power system. So again, in a high voltage testing of the surge arrestor, or we can say surge diverters, that has to be around a non-conductor. So as for the if we consider that there is a operating power frequencies, or we can say it is a voltages which are available at that operating power frequency. So there should be a short circuit conditions, and due to that also there is over voltages. So we can say whatever the surging or whatever with the like lightning strokes are there, that may be an impulse in a nature, or we can say that is impulse in a characters. Okay, so in such condition we need to discharge that high current to the ground, or we can say we need to recover all over our insulation which were damaged due to the surging So that time we should take consideration of voltage and current ratings of the surge diverters, which are shown in this table. So here there are three types of the, or three class of the diverters, that are A, B, C. And in this ABC class, first A class is standing for the low voltage, that is 230 volt to the 600 volt. And in that, whatever be the impulse current rating for the 8 by 20 microsecond, that is about around the 1500 or 2500 amperes. Then whatever be the high current rating, that is again around 5 to 6 times of the impulse current rating, that is 10,000 or 25,000 amperes. And whatever be the long duration, that may be around 50 to 500 microseconds, right? So that is for the low voltage. What will about the distribution voltages, that is 400 to 33 kV. So in that range, around 5,000 ampere for the time duration of 8 by 20 microseconds, and the 65,000 for the high current rating. For it is a for a 4 by 10 microseconds, means it is almost half of time. Okay, so again the time duration is for this 75 microseconds to the 1000 microseconds, so that is again increased. And last one, that is the station type lightning arresters. That means whatever the power station or generation station, transmission stations are there, like a which are above the 11 kV, or we can say which is equal to 11 kV or above its rating. So at that time, whatever be the impulse current rating, that is around 10,000 ampere for the 8 by 20 microsecond, and it is around 10 times for the high rating or high current rating. So that may be a 1 lakh amperes. So it having a longest duration of the time period, that is about 150 to 2000 microseconds. Okay, so this is all about the surge diverter voltage and current rating. And at that moment we can understand whatever be the lightning surges or surging strikes will be there, that time your current for the impulse high and another long duration. If suppose any surge stroke that remain for the 1 minute or remain for the 150 micro to 2000 microseconds, at that time how will it will its current will get changing, that is explained here. Okay, so let us move towards the various tests what that are conducted on the surge diverter. So first of all, power frequency spark over test in front of you, that is a routine test. And the test that may be a conducted using a series resistance. So that series resistance is used to limit the current if suppose there is a spark over occurring. So whenever that spark over will takes place, at that time that resistance that may be used to limit the current, whatever current is increasing. So that time that should be a arrestor should be withstand for the 1.5 times of the rated value of a voltage. And we will apply that for such a kind of 5 to 7 applications. So in that 5 to 7 we have to check whether that surge diverter is going to withstand or not. So if suppose out of that 5, if suppose one time it is getting failed, then we can say it is passing the test. But about 2, then we can say it is a failing to the pass this test. So such kind of test can be carried under the dry as well as wet conditions, so it will give a good quality. Then second one is a 100% standard impulse spark over test, and that test is again calculated, or we can say conducted, to ensure that whatever the diverter that are operating there, if suppose we are saying that the whatever be the operating voltages, what these are impulse in nature. So in such cases, that impulse generator that is adjusted for the standard impulse voltage level. So if suppose there is a present some kind of magnitude of voltage, and we have some specified values as per the standard specification, at that time whatever be the impulse generator is there, that has to be adjusted for the specific value as per the standard specifications. So suppose there is a spark over on arrestor, at every time there may be we will take a 10 samples, or we will take a testing of test objects for the 10 times. And there we are considering both polarities, means the positive polarity as well as negative polarity. And sometimes whatever be this test we are conducting, that should be starting at a voltage level which does not having a flashover at all, right? So means we are repeating that increasing stage, means we are increasing the voltage, again increasing voltage, again increasing voltage, until the 100% of the flashover occurring, we will increase the voltage one by one. So like that way we can conduct the test on its arrest. Then whatever be the magnitude of the voltages, that magnitude of voltage at suppose there we are considering around the 100% flashover occurring at that time, there is, we can say there is a required spark core voltage, and we can take calculation for that. Then third one, that is here, it is about the front of wave spark voltage. So in order to ensure that whatever be the high voltage testing we are conducting, in that, if suppose my surge diverter is flashing for every instantaneous or every point or every instant of the fronted wave for the high peak value, at that time we have to check that rate of rise of voltage, which will be around 100 kV per microsecond. So that should be the condition, and that is standing for the per 12 kilovolt. So per 12 kilovolt rating, we are saying that whatever be the rate of rise of our voltages, that should be how much? 100 kV per microsecond. So whatever be the estimated maximum steepnesses are there, so that waves are specified in the standard and specifications given by the Indian Standard Rule Book, right? So whatever be the test we are conducting, we're applying the spark or voltage up to its 100%, and at that time, whenever we are increasing the magnitude, at that time you will get the impulse wave. So whenever you will get impulse wave, that time you have to measure the spark over. So that we will say that may be a spark or voltages. So again according to that, you will get the volt versus time, means as per the time duration, however you are increasing the voltage, that you will get the volt time characteristics. So and as per this, you can calculate the arrestor characteristics for the uh, search arrestor, right? And such kind of intersections for the, if suppose I'll say that is the time duration curve. So that is the time and that is the voltage. So here you will get like increasing time, you are increasing the voltage, and that time somewhere at some places you will get the intersection. So whenever you are getting the intersection, at that time you can simply find out the line of slope, where you will have to identify the virtual steepness of the front waves. So that may be your front of wave spark or voltage, right? So this is all about the front of wave spark or test. And the next is that is residual voltage test. So again the same word, that is residual magnetism. So here again we are considering that in case of the residual voltage means what? So we'll understand that one again. So whenever we are carrying this test, at that time whatever the prorated diverter means, in suppose 3 kilovolt to the 12 kilovolt, that that rating of the range, kind of the diverters we will consider only for the testing purpose. So whatever be the voltage that is we're developing across whole the non-linear register units, that means NLRs, in case of such flow of surges, means if suppose some kind of the surges are occurring there, and due to that whatever be the surge voltage that is appearing, that is called as a residual voltage. So means during the flow of surge current through the arrestor, at that time whatever be the voltage developing across the NLSR, we can say non-linear register units, that is known as a residual voltages. So whenever that prorated arrestor that we can consider that is complete, so at that time the suitably halves or a section of an arrestor, including these gaps, whatever be the series gaps are there, or we can say non-linear series gaps are there. So these will have the proportion, right? This will have a proportion. So at that time we can say that is the complete arrestor which is passing the residual voltage test. So in such kind of test, how we will take the readings? So here, whatever be the standard impulse currents of the particular magnitude that we are going to apply, and at that time, whatever be the voltage is going to develop across the diverter, that should be recorded by using the CRO, or we can say by using the voltage divider. So that voltage divider will divide the voltage, and at that time it will be measured with the help of a cathode oscilloscope. So whatever be the magnitude of the current, that are we can say that maybe a 0.5 times, 1 times, or twice the rated current. So whenever we will get that such kind of magnitude, at that time we can calculate, we can find out a CRO, we will get the graph, and that graph will be the in between current magnitude and voltage magnitude. So whatever be the voltage and whatever be the current, so like that way you will get the graph on this, whatever be the like that way you will get the graph. So that graph will show you that however your voltage is going to develop across the diverter, the V1 we will have. That V1 means what? Rating of the complete unit. Then V2, that is rating of prorated unit testing, means whatever be the testing object is there. So for that one, V2 will be there. VR1, that is the residual voltage for this unit, and residual voltage for this unit, that means prorated unit. So whenever we will assume that V1 by V2 is equal to VR1 by okay. So as we know that whatever be the V1 rating of a complete unit, then V2 rating of the prorated unit, and again similarly VR1, VR2, that is the residual voltage for the complete unit and residual voltage for the prorated unit. So you will get V1 by V2 and is equal to VR1 by VR2. So let us, we will assume that whatever be the VRM, so that VRM will be the maximum permissible residual voltage. So that is we are considering for a particular unit. So in that case, whatever be the VRM by V1, that ratio we are considering, that is equal to R. So whenever we will get that ratio is nothing but what? It is a multiplying factor of the residual voltage. Okay. So in that cases, we can understand whatever be this multiplying factor is there, that is totally depends on the V1. So in that case, that diverter is said to pass the test. Means in case, if suppose my V1 is getting more, that time my R will get a decreasing, and in such cases, we will say my test is passed. Means whatever be the VR2 is equal to RV2. That is equal to RV2. So in such cases, we will say our arrestor or our diverter is passed the test. The next test on the surge diverter, that is the high current impulse test. So again, it will have some subtype of test. So basically, we will understand what is a high current impulse test on a surge diverter. So friends, whenever we are carrying this test at a prorated arrestor unit, means it is around a 3 to 12 kilovolt. And whenever we are conducting this test on this such kind of 3 to 12 kilovolt arrestor, at that time, the high current impulse wave around 4 by 10 microseconds of the peak value will be appeared, and that will be around mentioned as per the whatever be the verified, or we can say standard specifications that are. So in such cases, two applications that has to be done, and under these tests we will allow sufficient time to the cooling of particular unit, so at a room temperature also. So whenever we will say that this test is a passed, means we can say, if suppose the power frequency of a power spark or voltage before and after the test not differ by the 10%, then we can say this our diverter is passed the high current impulse test. If suppose my voltage and current waveform of the diverter do not differ significantly in the second application, then we can say this is a passed. Non-linear resistance, that is NLR elements of the diverters do not show any sign of puncture or flash, or means first condition that should not differ by more than 10%, second condition that should not be differ by the two applications, and third condition that is it will not show any sign of puncture or a damage or external flash. So at that moment we can say this surge diverter has passed high current impulse test. Again, this will have another type of these long duration impulse test, means this test having another type. So again, as we have already seen that high current impulse test has carried for the T to 12 kilovolt. So same time, long duration is carried for the 3 to 12 kilovolt. So the circuit which are used for the generating a rectangular waveform, or we can say rectangular impulse wave, which is considering an artificial transmission line. So in such cases, we will get the lumped inductance as well as capacitance. So what does it means? It means L and C. So for suppose the duration we are considering that whatever be the current pulse is there, that we are considering is given by the 2 into bracket n minus 1 under root LC. So where we can see n means number of stages or number of sections. So that has been used. And the L and C, that are the inductance and capacitance for this transmission line. So whenever that rectangular wave line will be generated, if whatever the surge impedance of the diverter, that is equal to under root L by C when we are providing a test current. So as per the standard specification, we will make 20 applications for the specified current in a separate groups. So whenever in every interval or about the 1 minute of the interval, we will take test and test, and at that time it will show a successive application. Then we will say that is a usual to record the waveform for first and second applications in the current wave. So such kind of diverters we can say that has passed the test when the power frequency spark or after and before the current test or current wave does not differ by the 10%. Then second will have that first and last application does not differ by 8%, and there should no any sign of puncture and other damage. Then we can say that long duration impulse current test has been passed. Then what is the B? That B is again type of the impulse current test, that is operating duty cycle test. In such kind of test, again we can say this test can be carried for the pro-rated units of arrestor and such kind of the better closeness of the actual conditions. So such kind of arrestors we should keep energized as it require a rated power frequency supply voltage, and in such kind of the arrestor we can say whatever be the rated impulse current wave, now that should be applied first as a phase angle around 30, from second AC voltage angle around 0. So like that way we will carry out the test, and around that if the power frequency whatever be the available, that power frequency should be whatever be the power frequency is there, that power frequency should be around we can say it should be around 10% up to the 90%. So such kind of things we can take for the consideration, and at this moment we can say whatever be the follow-on current is established, that having a current wave, if whatever be the power frequency voltage that is going to reduce the flow of current, then we can say whatever with the maximum of 10% current of the or voltage should get the compensate, right? So whenever we will say that follow on current period position is there, at that time whatever be the peak voltage that is appearing across the diverter, that will be that should be less than or equal to whatever be it is having a rated peak voltage. So if suppose we'll carry out the 20 applications, and in that 20 applications suppose all we will consider for the halting of a 1 minute, and in between this successive group for the half an hour, then we can say that arrestor will pass the test when its average power frequency spark over, that may be a before and after does not differ by the 10%, then residual voltage at the rated current does not vary by 10%, and follow on power frequency current that should be interrupted every time, and there should not know any sign of puncture and a sign of flashover. Then and only then we can say the testing of a surge diverter in a high impulse test with a duty cycle or voltage duty cycle, we can say it is passed by the diverter. Then what are the other tests? Then other tests in such diverters are a basic test, that is a routine test, mechanical test like a porosity test, temperature cycle test, and others like a pressure relief, then voltage withstand state, as we had already seen that in an insulator problem, then switching surge flashover test, and the pollution test. So these all are the various types of the test which are carried under the surge diverters, or we can say surge arresters. So the session is open for the question answer. If suppose you have any doubt for the surge diverters and arrestor, is there any doubt? Is there any doubt? Someone should respond. Is there any doubt? Am I audible? Sakshi, Akshay, Harshvardhan, am I audible?
Yes, sir.
So is there any doubt?
No, sir.
Okay, fine. So let us move towards the end of unit, that is for the high voltage test on radio interference. So first of all, we will understand what are the high voltage test on radio. So as we know that there are many electrical apparatus like a transformer, like a line conductors, like a rotating machines that are producing a electrical signal. So whatever the signal they are producing that are in line with the radio and high frequency, like a television band, like a microwave band. So whatever be the ranges of these frequency elements or frequency devices, that will be generated in also our electrical apparatus. So whatever be the signals are there, like a wave signals are there, that will increases due to the corona discharges in air. So whatever be the corona discharge in the air or atmosphere conditions due to the partial discharges in an insulation, or we can say whatever be the sparking at a commutator, or we can say whatever be the brush gear in a rotating machine. So it is very important that whatever be the interference between these our actual signal and whatever be the radial signals are there, so that should be in range of the acceptable level. So if suppose that are not in acceptable level, such cases at the time high voltage test on this radio interference voltage measurements are very important. So let us understand that whatever be the surface condition for the overhead conductors that are again considered for the high voltage stresses, and in cases of the various atmospheric conditions where we can see that atmosphere conditions are going to vary time to time, so it will have very great influences on the magnitude of noise voltage that are produced. So if suppose there is a solid insulators and that having a bonding between porcelain and a metal pin, at that time whenever we consider the binding of a high voltage conductor and the insulator surface, at that time you will have the surfactant pollutant which will be available on the source surface of this insulator as a source of noise, right? So in such cases we need to take a measurement of the radio interference voltages, right? So that radio interference voltage means RIV, like a RIV. We can write that into another way, that is RIV. So whatever be the measurement of that RIV means whatever be the noise generated in the radio frequency band. So it may be a result of a corona, or we can say whatever be the partial discharge due to the whatever be the insulation failures. So at that time in high voltage apparatus that can be measured by the radio frequency line to ground voltage. Okay, and the second one that is by as an interfering field by means of antenna, so that is known as radiated radio interference voltage. And first one, that is the radio interference influence voltage, means RIV and RI. So first one is that radio influence voltage, and second one is radio interference voltage. So in such cases whatever be the systems will be there, that system we will understand first, and then we will go for the deep knowledge or deep testing of these kind of measurements. So measurement of radio interference voltages means a high voltage test that are occurred on a radio interference, means there is a radio noise meter which are used in a laboratory, and that are used in a laboratory for a major for a particular purpose, means there may be a portable radio receiver with its local oscillator. So whenever a radio frequency amplifier, or we can say whatever be the frequency mixer there, so that intermediate frequency amplifier will detect the same waves which are generated by the radio waves, and where it will consider, or it will check whether it is operating in a frequency range of around 150 kilohertz to the 30 megahertz. So if suppose that is into range, at that moment we will understand, the high voltage test, which are as we know that there is a multiple wavelength, so we can say there is a multiple input circuit which are accommodating into the a number of pickup devices. Okay, so suppose there is a attenuators, there is a calibrators, there is output circuits which are containing the detectors or some kind of meters. So such all detector circuits which will having a diode detecting circuit. So that diodes are always connected in series. So for that purpose, series resistances will charge the RC circuits, or we can say capacitance circuit, right? So whatever be the detector circuits that are provided, that whatever be the circuits which will having a measures that will measures of the voltage values, like the average value of the voltage or the peak value or the quasi peak value, means how we can say this. So this, suppose this is a waveform. Okay, so you know that this is the peak value. Okay, so this is the quasi value, and this will be our average value, means average value will be lays around 0.0707, right? So at that moment your average value will be rise. Peak value means that will be at 100%, and your quasi value means it will be at 256, 0.256. Like that way you will get the three values, right? So whenever you will get these values, at that time we will say whatever be the detection circuit is there, that detection circuit may takes care of the whatever be the values we are spreading over there. And in case of such values, we will understand the importance of the whatever be the center frequency of the waveform, which will having a pass band. So there is a bands. Okay, so if suppose there is a one tower, so this tower will have his its a frequency band. Means we can say that with the frequency band, sometimes we say that my mobile network does not having a range. Means what? Means you are out of this range band, or you are out of this bandwidth, right? So means whenever and one more thing that I will tell you, that if suppose there is a television in your home, and if suppose it is an on condition, and you are calling or you are speaking on a phone, you are speaking on a phone, so at that time sometime some kind of noise will be there. So that noise is nothing but what? That means your waves are interfering itself. So whenever your voltmeter that are provided at the end of the detection circuitry, that will gives you a input impedance around the 50 to 75 ohm. So that will be the measurement radio interference. So there are some test circuits are there again. So the test circuits that are for the measurement of such kind of RIV. So these RIV measurements are shown in a figure. These three figures are used there. So what are the important components of this figure? So here I will explain you important component. So radio frequency chokes are there, so which are used to limit the loss of this RIV voltage, and that will conduct energy from each and every sample. So here that V stands for the voltage, that V stands for the voltage control unit. This is my voltmeter, this is my control unit, this stands for the my high voltage transformer. And here this M stands for this whatever the radio noise meter, for the impedance which should be around 50 to 75. The CS stands for the coaxial cable that is conducting here. Okay, then whatever be the CL, that is capacitance, that is inductor. Okay, so S1 stands for this is a one kind of switch. Okay, so this is the one kind of figure. Then another one that is for the RIV, which is measuring around the 150 kilowatts to 30 megahertz. And second is for the measurement of the RIV from conductors of an energized system. So in such cases, there is again coaxial cable. This R1 stands for again for the input impedances, and as well as M stands for the meter, which is used for the radio noise meter. Then again L1 will be the varying value of the inductance and such kind of the measuring input impedance. So such kind of figure, again testing circuit that can be used for the detection of such kind of interference. And the last one, that is the measure by the as per the British standard, that is here that high voltage transformer is there. So it is very limited and it is having a protective smart spark gaps also. So everywhere the British standard, you as per the British standard, RIV measurement circuit test has been used. So here you can see whatever with the coupling capacitors are used, that coupling capacitors we can say, which is having like that way, this coupling capacitor. Here is a coupling capacitor, then here is a coupling capacitor, then again you can see in this the C2, that is the coupling capacitor. So these coupling capacitors which are having a rating of 0.001 microfarad, so it should be free from the noise and it will have the operating range, and whatever with the resistors are connected, that R should have a 800 volt, or it should be equal to the 800 ohm. So whatever be the value that will indicate by the a meter, that should have be a conductor in between the high voltage test on the radio noise. Okay, so such kind of things we will understood as this is used for the measurement purpose. Then in such cases, whatever be the high voltage test on the radio noise measurement, meter measurement, that are already I have stated that. So some of the information regarding some standard specification that are we are using. So in such cases, whatever be the frequency range measurements, or we can say whatever be the band pass or bandwidth characteristics are there. So that are again mentioned as per the open circuit as well as the detection circuit. So whenever our transmission system is around 400 kV or it is above the 400 kV, at that time such kind of the corrective measurements we need to take into picture, and that time you have to minimize the television as well as the radio band waves, or whatever with the band noise, or whatever with the frequency interference due to such kind of the radio as well as television, that should be stopped. Okay, so this is all about the unit number 5. And now if suppose you have any question, you have any doubt, please let me know so we can discuss here. Any doubt? Yes, please let me know if suppose you have any doubt.
No, sir.
Yes, anyone? Any doubt? Let me know whether you have any doubt or not. Okay, there will be a one objective question, and that will be fed into your poll. Okay, so okay, just hold on for a second. Okay, here is a question in front of you. So the question is that partial discharge can be detected by. So let me know the answer. Yes. What will be the answer? Okay, four people has answered, two out of that saying that listening to hissing sound. So partial discharge. What does it mean by partial discharge? Partial discharge means what? It means whatever be the cable you are having, whatever be the conductor you are having, that all conductor or all the electrical apparatus that will leak the voltage or leak the current, that means it is getting detected by a partial discharge. So that can be detected by what? So first answer, that is the listening to hissing sound. Second, that alpha and uh, whatever be the optical cables are there. Then all of above. So out of 10, 5 saying answer A, 5 saying answer D. So still 1 minute will be there. I will keep 1 minute more. Yes. Okay, fine. Out of 16, 10 are saying that listening to the hissing sound, and the 6 are saying that all of above. So correct answer is, I'll show you how you have all responded. So see, you can see whatever be your answer. So 38% are saying that all of above, and 63% are saying that listening to hissing sound. So correct answer is all of the above. Okay, so means listening to the hissing sound, alpha higher than tan delta, then optical methods. All that methods are used to detect the whatever be okay. So okay, so today we will take online test for the unit number 4 and unit number 5. Okay, so that online test I will post around 1 p.m. and second at a time I will post both tests. So you will have to appear for the both online test, and you have to finish that up to today evening around 7 p.m. So okay, that will be the useful for your term work marks. So let us discuss for the syllabus for the sixth number unit. Okay, I hope the syllabus in front of you. Is it visible? Okay, fine. So this is the last unit, that is the design, planning, and layout of the design, planning, and layout of the high voltage laboratory. So this is our unit number, last unit number. Basics of foundation of technical, that prerequisite you should have understood. Okay. Okay, then second thing, that is all about the what are objectives that are being understood by you. So that that unit maybe introduced to you that various factors regarding the electrical power system foundation. So how we are going to design the high voltage laboratory. Then you will be able to understand that classification of high voltage laboratory. So which type of laboratories are there. Then again, we will understand what are the sizing and the rating of the high voltage laboratories are there. So that will also we will understand. Okay, so this is all about the objectives of the number 6 unit, and that unit is about the design of the laboratory or high voltage laboratory. So once we will finish this unit, after that completing units, we will understand the various factors for a high voltage laboratory. Then we will understand whatever the process for the high sizing and rating of the high voltage laboratory, and we will understand that use of various tools and the devices for high voltage laboratory. Okay, so this all we will understand easily once we will finish this unit number 6. So what are the what are the contents that we are going to understand in a that high voltage laboratory. So first of all, that test facilities provided in high voltage laboratory means which kind of test we can conduct, that are the facilities. Then what are the activities and studies that we will do in high voltage laboratory. Then also, what are the various types of the laboratories? That means classification of high voltage laboratory, size and rating of the high voltage laboratory. Means if suppose we are developing a high voltage laboratory, then how this laboratory will have its sizing, how it will have its rating of the equipment, and the grounding of impulse testing laboratory. Means how this laboratory is grounded. Means if suppose we are testing any equipment and if there is any damage, so that time we will understand how this will get a grounding, or how that whatever with the high voltage current or high current that will goes to ground. Okay, so this will we will understand easily in a unit number 6. Okay, so for now we will stop here, and let me take in attendance. Okay, fine, you can leave the class.